Hi, welcome to today's intermediate algebra lesson. Today we're covering section 3.4, linear inequalities. And specifically, we're going to be graphing these. So those are going to have variables x and y, and basically this is going to be a lot like graphing regular lines. So we're going to have a couple of other steps, but if you can graph lines, it's going to go really well for you. Alright, so here's the thing. I have that video out there on graph lines. So you need to watch that first, make sure you know how to graph lines. And then here we're going to really talk about doing stuff you need to do in inequalities. So here's how it's going to go. An example of the linear inequality of two variables is something like this with y is greater than 3x minus 2. So notice that it looks a lot like our normal way to line, except that we don't have an equal sign now, have some sort of inequality in this case, greater than sign. And so we're going to do a lot of the same stuff, and that's going to be what makes it really nice for us. So step one, we need to graph the line. You can do this either by making equal values, find points that are on the line, and drawing the line that way. Or in this case, for instance, we have a little intercept that works, so you could plot by intercept, and then you still find that point. Either way, I'm not hard to pick, but you can go the line. Now, we need to graph the line. Here's the catch. The line may or may not be hard for us to success that. So we're going to use a solid line if less than or equal to greater than or equal to, because then that line is included in the solution. And when you use dotted line, less than greater. So with the example that I have above, y is greater than x minus 2, because it's greater than you use the dotted lines, that boundary line itself is not going to be included. Once you have a line, now it's time to move on, and you're going to figure out which side of that line you need to take. So it's really straightforward. The easiest way to do it, and the most consistently correct way to do it, is to take any point that is not on the line and plug it into the inequality. Okay, so we take it and plug it in. If that point works, if that point makes a true statement, then we change the side that point is on. If the point does not work, we change the other side. One side has to work, and only one side. And so really, pick any point when it's not on the line, and pick 0, you can't. That's always a great point to pick. But if one point on the side would work, every other point on that side would work. And if it doesn't work, nothing on that side would work. It's always one side or the other every single time. So we're going to look at it. We'll do the same thing for a second, and give a second, since they're going to be word. So hang on. All right. So let's go ahead and look at the graph for y is greater than 3x minus 2. So for starters, I graphed the line. I know that my y-intercept is -2 and my slope is 3. So that's how I went about graphing this. I put a dot on the y-axis at -2 because, again, that's my y-intercept. And since the slope is 3, from that point, I just went up 3 and to the right 1 to get a second point, and that gave me my 2 points. Now, you'll notice that this time, my line is dotted. Okay, and that's, again, because we have a strictly greater than sign. Remember, in order to make a solid line, we have to have greater than or equal to or less than or equal to. Be careful with this. This is a really easy thing to forget about. Okay, people do these really well, and then they just forget about the dotted lines. So please be careful with these graphs. I just can't stress that enough. Be careful. It's a really easy thing to forget about. It's very embarrassing, but I sometimes forget that myself when teaching class, and so then my students always laugh at me, and that's great for them, but kind of embarrassing. So anyway, don't forget the dotted lines if you should have one. So here's our line. Now you'll see that I put a big circle around the origin, and you can see I also labeled that point 0, 0. So remember, step 2 in graphing these was to pick a point not on the line, and that's really important. The line is the boundary. One side will work, the other side won't. In this case, you can see I already shaded this kind of top left side. That's the side that's going to work. But the easiest way to figure that out is just to pick a point. And so if the origin, if 0, 0 is not on your line, pick the origin. If it is on your line, you have to pick something else. But hey, in this case, I can use 0, 0. So we have 0, 0, and you can see over here, I went to the effort to plug it in. So I put in 0 for y because that's the y coordinate of the point I picked, and I put in 0 for x. Now, you'll see I have a question mark here. Basically, I'm asking, is this true? If I put in the 2 zeros, do I get a true statement? If I do, then, like in this case, I end up shading that side. So 3 times 0 is 0. So I end up with 0 being greater than -2. And that's certainly a true statement, right? Negative numbers are all smaller than 0. So that's certainly true, which is why I then shaded the side that 0, 0 is on. So that's one example here, and that's really all there is to it. So if you can graph the lines, the only things you really need to keep track of is it a solid or a dotted line? Be really careful with that. That's so easy to make a mistake on. And then just pick a point. And when you pick it, plug it in. If it works, shade that side. If it doesn't, then we will shade this side, the other side. All right, let's look at another example. Okay, for my last example in this section, -2x plus 5y is greater than or equal to 10. Now, I have a bit of a mess going on here, so please try and follow along or go back and watch it twice. I don't know. But here we go. So for starters, I need to graph this line again. Now notice this time I have the line underneath the inequality, so it will be a solid line, which you can kind of see over here behind me. All right, so I started by, I needed 2 ordered pairs. This time, since I wasn't in slope-intercept form, I just plugged in 0 for x to find the y value that went with it, the y-intercept. And then I plugged in 0 for y to find the x value, the x-intercept. And you can see I did that work over here. Not this bit, this is different. I plugged in 0 for x here, and that's how I got y is equal to 2. Then I plugged in 0 for y, and when I solved, that's where the x equals -5 came from. And that's my 2 ordered pairs. So I brought that over here, and I put those ordered pairs on the graph. 0, 2 is my y-intercept, and -5, 0 is my x-intercept. Again, 2 points makes the line. In this case, I get a solid line, again, because we do have the line under there that gives us the equal, and so we get to use the whole line. So again, just like on the last example, I picked a point that's not on the line. I will pick 0, 0 every single time if I can. It's such a nice, easy point to plug in. You can pick something else, it just has to be not on the line. But honestly, why would you pick something else? If you can do it, use 0, 0. So I took 0, 0, and this is where I plugged it in. So you can see I put in 0 for x and 0 for y, which left me with 0 is greater than or equal to 10. That's not true, right? 0 is not bigger than 10. And since that's false, you'll notice I didn't shade the side with 0, 0. This time I shaded the other side. So remember, if you get a true statement, shade the side the point is on. If you get a false statement, shade the other side. And so there you go. That's graphing linear inequalities. This is really one of the nicer things that we do because most of you probably already have a pretty good feel for graphing lines. Again, if you don't, go watch that other video and make sure you know how to graph lines. But yeah, there you go. Have a wonderful day.